be learning about AWS Cloud Computing. So let's get started. Give me a minute to share my screen and then we can begin. All right. All right, let's begin. Welcome to AWS Cloud Computing. First, what is cloud computing? The definition of cloud computing is an on-demand delivery of compute power, database storage, applications, and other IT resources through a cloud services platform via the internet with pay-as-you-go pricing. AWS started its cloud computing back in 2006, where they sold IT infrastructure services to businesses as web services. This provided a simple way to access servers, storage, databases, as well as a broad set of application services all across the internet. A cloud services platform, such as AWS, owns and maintains the network-connected hardware required for these services, while you, the user, provision and use whatever you need. This helps you build and run applications. The cloud can also be used for deployment and management of applications. AWS Cloud is available to hundreds of thousands of customers across 190 countries. Its powerful resources are given at a low operational cost. Classically, provisioning services can at times be a Goldilocks problem, where it's hard to get it just right. However, with AWS, you can elastically scale up or down the services that you need. Some benefits of the cloud include the ability to deliver innovative new features to the market quicker. This means that you can focus on adding differentiated value. It also makes new ideas feasible that were once thought of as out of reach. Experimentation can now become fast and low risk, and it can be adjusted to fit any workload. The cloud also helps businesses serve their customers on a global scale without the need for expensive and time-consuming expansion. The cloud can help deploy web services using tools and languages such as Chef, Visual Studio, PHP, Java, Python, and more. This helps connect to personal infrastructure by a private dedicated connectivity. So some more cloud benefits. Trading capital expense for variable expense. Instead of paying a certain fee every time, the AWS cloud allows you to pay for only what you consume, and you only pay when you are consuming. It also benefits from massive economies of scale. This leads to lower variable costs and higher economies of scale for you. It also will ultimately lead to lower prices. Next, you can also stop guessing about capacity. As I've stated, you can use as much or as little of the cloud as you need it, and you can scale up or down your use whenever necessary with only a few minutes of notice. Furthermore, you can increase speed and agility. You can reduce the time it takes to make certain resources available, and you can cause a large increase in agility due to cost and time to experiment being extraordinarily lower. Furthermore, you can stop spending money running and maintaining data centers. Instead, you can focus on your own customers. Next, you can go global in minutes. You can deploy your application in multiple regions around the world extremely quickly in just a few simple and easy steps. This means that you can provide lower latency or delay before the transfer of data, and just a better experience for your customers overall at a fraction of the cost. Next, let's discuss total cost of ownership. Total cost of ownership reduces the need to invest in large capital decisions. Instead, you are provided with a pay-as-you-go model that allows you to invest in the capacity that you will need and use. Total cost of ownership calculators allow you to estimate the costs and savings of switching to the cloud. Calculators also modify certain assumptions to best meet your business's needs. Calculators also provide directional guidance on possible savings that you may achieve by switching to the cloud. The tool is built on an underlying calculation model, and its goal is to generate a fair assessment of value that a customer may achieve. However, it's important to note that these TCO calculators are only used as an approximation. And as you can see in the image, this person could save 69% by moving to the AWS cloud. And this is an example of how switching from on-premise to AWS can be beneficial and how a total cost of ownership calculator can project your savings. So here's a video about more information about cloud computing, which will be in the link below. Next, the types of cloud computing. So there's several different models of cloud computing. They each allow for a different amount of control of your web services. There are three main types: infrastructure as a service, IaaS, platform as a service, PaaS, and software as a service, SaaS. Let's talk about each. First, infrastructure as a service. This contains the basic building blocks for cloud IT. You are typically providing access to networking features, computers, and data storage space. It offers the highest level of flexibility and management. This is the most similar to existing IT resources, and it allows for instant computing infrastructure. IaaS gives the user the most control. Platform as a service removes the need for organizations to manage any underlying infrastructure. This includes stuff like hardware and operating system. Instead, you're allowed to focus on the deployment and management of your applications. This helps business owners become overall more efficient. This also disregards human concern over resource procurement, capacity planning, software maintenance, patching, and more. This is achieved by a combination of hardware and software components. Next, software as a service. This provides customers with a completed product that is run and managed by the service provider. Software as a service is usually referred to as end-user applications. No user concern is given about service maintenance or how infrastructure is managed. Instead, you only need to know how you will use the software. An example of software as a service is a web-based email. This sends and receives emails, and the user does not have to worry about managing any feature additions, but instead just how they will use the email. Alright, so again, here's an extra information video that will be linked below. Next, how to deploy cloud infrastructure easily. There are 4 key areas to do so. First, the cloud has highly trusted global infrastructure. This is designed for high security and availability needs of the large enterprises. It offers capabilities that restrict unauthorized access or usage without sacrificing any flexibility. It also has a backup for all features. Furthermore, the cloud provides broad compatibility with all popular workloads. You can spin up virtual servers, hard drives, databases, networks, and more easily. You can also easily set up virtual servers using Linux or Windows. Next, fast and secure private networking. You can provision a private section of the AWS cloud that you define and control. This is done with simple IP networking. The cloud environment then will become an extension of your on-premise environment, and you can use a standard pipe that encrypts data when it moves from your environment to the cloud. More data creates dedicated network from your existing data centers to AWS. This will give you predictable network and a performance increase as you bypass the public internet. Some tools to control access to all cloud resources are also provided. These create and manage users and integrate with your existing identity systems. This gives greater flexibility to rapidly create new apps, lower costs for any existing apps, and benefit from the global infrastructure and security that AWS provides. Next, the cloud. Cloud-based applications are fully deployed in the cloud. The cloud model are when applications in the cloud are created solely in the cloud. Or another way they could be created is if they are migrated completely from existing infrastructure to take advantage of any cloud benefits. Cloud-based applications can also be built on low-level infrastructure. They can also use higher services that provide detachment for management, architecting, and scaling goals. Next, the hybrid model. The hybrid model is a way to connect infrastructure and applications. You can connect cloud-based resources and existing resources. A common method of hybrid deployment is to extend and grow an organization's infrastructure into the cloud while connecting cloud resources to the internal system. You can run applications in both the cloud and on-premise, and you can access AWS wherever necessary. Next, on-premise. On-premise models are referred to as the private cloud. They use virtualization and resource management tools. On-premise deployment leads to the inability to receive any cloud computing benefits. This is usually used to provide dedicated resources to a company. Typically, the on-premise matches existing previous IT infrastructure. It uses application management and virtualization technologies to attempt to increase resource usage. So here is an additional information video regarding cloud versus hybrid versus on-premise models. Next, let's discuss security. So AWS's infrastructure installs safeguards to protect privacy. Data is kept in highly secured data centers. They manage dozens of compliance programs, and segments of compliance have already been completed. AWS has the highest security without the user having to manage their own facility. This saves money at the same time as all the other cloud benefits. You can also scale your security with your AWS cloud usage, and you can still maintain the security regardless of how big your cloud is. Here's an additional information video about AWS security. Now let's discuss some of the services that AWS can provide. First up, we have AWS Analytics Service. This is a set of services that handle every step of the analytics process. The services are powerful, flexible, yet simple to use. This enables organizations to put unorganized data to work efficiently. Some examples of this include Elasticsearch, Kinesis, and Redshift and Athena. Amazon Elasticsearch is an open source search and analytics engine used to log analytics, real-time application monitoring, as well as user-click analytics. Amazon Kinesis allows you to absorb, buffer, and process streaming data to find any insights from data promptly. Amazon Redshift can ask questions and combine exabytes, or a 10 to the 18th byte, of organized and disorganized data across your data warehouse, operational database, and data lake, which is a centralized repository that allows you to store all of your unstructured and structured data at any scale. And it does all of this using a language called Standard Query Language, or SQL. Amazon Athena is an interactive question service that makes it simple to analyze the data in Amazon Edge 3 using SQL. AWS Compute Services are the next type. These services offer things that can deploy, run, and scale applications, as well as virtual servers, containers, and code. Examples include Amazon EC2, which obtains servers quickly and inexpensively, Amazon Lightsail, which creates a virtual private server, VPS, and Amazon Elastic Container Service. This runs in Docker containers, which contain software that are in standardized units known as containers. And then these containers hold everything a software will need to run, including libraries, system tools, code, runtime, and more. Here's the next type is AWS Database Services. So these are necessary databases for applications, such as any managed relational, non-relational data warehouse, in-memory data storing graph databases. Some two examples include Amazon DynamoDB and Amazon RDS. Amazon DynamoDB is a fast and flexible database service for any workload, where once again you will only pay for what you utilize. It is a key value database that delivers nearly instantaneous single-digit performance at any scale. It is built to handle internet applications, and it is a fully managed service so that you, the user, only have to worry about how you use it, and it handles more than 1 trillion requests per section. Amazon Relational Database Service, or RDS, is a service with 6 well-known database engines, and it can be set up, operated, and scaled in just a few simple steps. Alright, so our final section here is just discussing some more of these tools. So next we have AWS Developer Tools. These contain code and automatically create, evaluate, and deploy applications. There are a set of services that quickly and carefully deliver software. Services store and hold control of your application source code, and it is used for constant integration, continuous delivery, infrastructure as code, and monitoring. Some examples include AWS Code Pipeline, which can create an end-to-end software release workflow using services. It is a continuous delivery service that automates the release of pipelines in order to have fast and reliable applications as well as infrastructure updates. It effectively and efficiently delivers features and updates. AWS Cloud Development Kit is another example. The AWS Cloud Development Kit is an open software development structure to define your cloud application resources using any known programming languages that can be used with the cloud. This supplies cloud applications and requires you to perform manual actions, write any custom scripts, maintain templates, or learn some domain specific languages. But AWS CDK utilizes familiarity and expressive power of the programming languages to model your applications for you. AWS Code Deploy is a tool that installs applications and updates any servers. This lowers workload on your developers and quickens the release of new products and features. Code Deploy makes it simple for users to rapidly and efficiently release new features, help avoid downtime during application deployment, and help deal with the complex structure of updating applications. Some benefits include automated deployments, minimized downtime, centralized control, and the fact that code deploy is very easy to adopt. Next, we have AWS management tools. These allow you to provision, monitor, and set forth your cloud environment, and you can maintain stable control without restricting your development speed. AWS CloudWatch is a service which was built for developers, system operators, site reliability engineers, and IT managers. It is built to provide information and insights to monitor your applications, understand and respond to system wide performance changes, optimize your resource utilization, as well as get an allied view of operational health. This gathers monitoring and operational data in the form of logs, metrics, and events, which all helps to provide you with a linked-in view of your AWS's resources and applications and services that run on AWS, as well as any of your on-premise servers. AWS CloudFormation provides a common language to supply important assets in the cloud, and provisions can be automated to be sent over and over again. Models infrastructure using a simple text file. AWS Systems Manager allows full control of the structure of AWS and automates tasks that are needed for smooth operations, which help detect problems quickly and guarantee security and compliance. Next, we have AWS networking and content delivery services. So these are focused on isolating your cloud's infrastructure, scaling any request handling capacity, and connecting your physical network to your private virtual network. The networking products work together to meet any requirements from you, the user. So an example we have here is Elastic Load Balancing, which coordinates with Amazon Virtual Private Cloud or VPC to give networking and security features. They distribute application traffic among different services, and it handles traffic in one or multiple availability zones or data centers. It helps improve your scalability or adjustability of applications. Next, we have AWS Storage Services. So this is a reliable, secure, and adjustable location for your data. AWS offers a wide variety of cloud storage services to support both application and archival requirements. Archival requirements are the dates when things can be archived or stored away and very hard to get back. So one can choose from different options to build the base of your cloud storage management solution. And in AWS, the different types of storage services include object storage, file storage, block storage, backup, data transfer, and edge computing and storage. So here's a video about all of the AWS services that we just covered.
Hi all, this is
Alright, that is it for today. We hope you enjoyed. As always, any of the videos that you saw will be linked below in the comment section. We hope you learned something, and we'll see you next week. Thank you.